Good evening, student in the house and all viewers. So there is a question here that's under electrolysis. So an element T of relative atomic mass 56 was deposited by electrolysis. So that's a process by which a chemical compound is being decomposed, in with the emission or the liberation of current through the circuit. So this kind of a question is basically telling us that, okay, how can we relate some calculations into electrolysis? And this is what we want to do right now. So the atomic mass, the relative atomic mass of element T is 56. That's our solution. So the relative atomic mass of element T equals to 56. Then the answer that was deposited by electrolysis, if 1.99 gram of the element was deposited on the cathode. So the mass of the element now, 1.99 gram, was deposited on the cathode. So the cathode is acting as a negative electrode there, so in which reduction takes place. We all know that. So when 1.90 ampere of current, so the current given to us here is 1.90 ampere of current. So flows for 1 hour. So that's the time. The time here is 1 hour. 1 hour has 30 minutes, right? 30 minutes. So we convert this one everything to seconds. So how many seconds make an hour? That's 3,600 seconds plus. So we convert 30 minutes to seconds. That gives us 1,800. Look at it very well. So if you add 3,600 plus 1,000, 800. So that will give us. So that's 5,400 seconds. So the total seconds we are going to have here is 5,400 seconds for the total time. So what's now the charge? The charge of element T to the charge. We don't know the charge now. We don't know the charge. So we can solve it in different ways. Now let me give you some ways that we can solve this question. We can use this method. For instance, we can use that Q equals to what? IT. We know that already. Q equals to IT. Q equals to IT. Now, and then we don't know Q. So R is 1.9, T is 5,400. So if we multiply 1.9 times 5,400, so you multiply with the